Hi dear, today we'll see the reaction of metals with solutions of other metals also. Okay, last class we have seen the reaction of metals and non-metals separately with oxygen, hydrogen, water and some acids, right? So today we'll see the reaction of metals with solutions of other metals also. Okay, so we have already seen this one, but here it is given in a different name, that's all, right? So you know the displacement reaction, right? We have studied in the first chapter, right? The reactive metals can displace less reactive metal from their compound. This is a displacement reaction, right? In solutions or in molten form. That is what metal A plus solutions or salt solution of metal B. Okay. If A is more reactive, then it will replace the B from this solution. Correct. This from this compound. So it gives salt solution of A plus metal B. That means this we have done as a experiment activity also. Iron plus copper sulfate gives iron sulfate plus copper. So if you dip, you know the color of this copper sulfate solution is blue in color, right? Blue in color. If you dip a nail here, if you dip a nail in that, slowly the reaction displace this iron. This iron will displace all the copper present in the copper sulfate solution. Okay, and it becomes FeSO4. What happens? So the solution becomes slightly begins to fade because the copper sulfate solution is blue in color. When the reaction start, it begins to fade. It begins to fade, and you can see the color change. The copper, it becomes, the copper is separated, right? You can see the brown color deposition over here. This is copper. Okay, so this solution become colorless or fades. This is because of FeSO4, but this is copper sulfate, CuSO4. Okay, so here F iron is more reactive than copper, that's why it is replaced the copper from its compound. Okay, so how will you find it which is more reactive or not? Okay, based on the displacement reaction conducted, some of the metals with this reactivity is given here. Okay, so this is decreasing from top to bottom, and the more reactive metal is potassium. Next, sodium, the reaction is reducing. This is most reactive and this is less reactive. And magnesium, aluminum, zinc, iron, we have done this one experiment, right? Iron is present here, and copper is here. So that means iron is more reactive than copper. That's why this iron replaces copper from copper sulfate. Okay, here the hydrogen is included in this series, but it is a non-metal. But here they included because it is a electropositive in nature. Okay, usually non-metals are electronegative in nature, but here the hydrogen is electropositive, right? So they included here. Okay, so this is a reactivity series. You can use the mnemonics to remember this. Please stop calling me a zebra. I like her calling me smart guy. Okay, smart guy. So like this you can remember this as this. Remember this, we already studied in the chapter 1 itself. Okay, this is a reaction of metals with the solution of other metals also. Okay, so we are seeing that some of the metals will react is more reactive, or some of the metals are less reactive, right? So which decides the reactivity of that all those things? Okay, based on the valence shell, you know, you have studied in the 9th standard, right? You have 4 shells, namely K shell, and in the nucleus we will have K shell, L shell, M shell and N shell, right? It varies with 2n square, right? So here this is K, L, M, N. Okay, so based on the valence shell, number of electrons present in the present in the each element gives the combining capacity of that element, right? Combining capacity of that element. Okay, next we'll see the reaction of metals with non-metals. Okay, see if you look at this, if you see the noble gas, and we have studied about this noble gas, is less reactive because it is complete. All the shells are complete. Here it is 2. K shell should have 2, and L shell should have 8 electrons, and here 18, or octet root can satisfy octet, right? So noble, as if you see the noble gas, helium, neon and argon, everything is complete. So it is less reactive. Based on the number of electrons present in that gives the valence electron will give the combining capacity of that element. Here it is complete, so it will not react almost. It has less reactive power. Okay, if you see this metal, sodium, magnesium, aluminum, potassium and calcium, if you see this, here one M shell contains one electron. Here magnesium contains 2, aluminum contains 3, and potassium have 1 and 2 at its valence shell. Okay. Here in the non-metals also, here this complete, if it needs 3 more electron to complete the octet rule. Here 2 electron, here 1 electron, here 3, and here it is 2, and here 1. Okay, so based on the electrons present in the outermost shell, that is valence shell, decides the combining capacity or reactivity of the elements with the other elements. Okay, right? So when the metal reacts with non-metals, you know that metals are electropositive in nature and the non-metals are electronegative in nature, right? How does it combine? If a metal combines with the non-metal, see the sodium, we'll take the sodium. Here atomic number of sodium is 11, right? Atomic number of sodium is 11. Sodium is 11. That means it has 11 proton and 11 electrons will be there, right? 11 proton and 11 electron will be there. That's why it is neutral in nature. Okay. So if you take this, here in the K shell, it has 2 electrons, and L shell 1, 2, 3, 4, 5, 6, 7, 8. Totally 10 electrons are over, and only 1 electron is present in the M shell. Okay. Okay. It is difficult to get remaining 7 electrons to complete the octet rule. Instead of that, it can leave this electron, right? It can leave this electron. That's why it becomes Na plus. Why it is Na plus means, if 1 electron is removed from this, means it becomes 10 electron. Okay, which is dominating, 11 proton or 10 electron? 11 proton. That's why it is indicated by Na plus. It has one positive, one proton is there, extra proton is there. Okay, Na plus 1 electron. Okay, clear on this? Likewise, chlorine. For chlorine, we'll take this chlorine. It has atomic number of this chlorine is 17, right? 17 proton is there, 17 electron will be there, right? So 2 electrons, first shell is completed, second shell 1, 2, 3, 4, 5, 6, 7, 8 is completed. Again 7 is there. 1, 2, 3, 4, 5, 6, 7. Okay, it is difficult to remove all this 7 electron. Instead, it can take 1 electron. It can get 1 electron from other thing and it can complete that. Okay, it gains 1 electrons, mean it becomes 18E, right? Which one is dominating, 17P or 18E? so it is extra, it has one extra electron, so it becomes Cl minus, negative, because electrons are dominating, so Cl minus, and it has one electron. Okay, one electron with that. Okay, so it gains one electron and it becomes Cl minus. Okay, here you should not put this one. Cl plus one electron will gain Cl minus. Okay, so what happens when this sodium, metal and non-metal reacts? So this chlorine requires one electron, and sodium will lose one electron. So this the electrons and lost by this sodium will be received by this electron acceptor, this chlorine. Okay, so Na plus Cl minus, right, gives NaCl. Okay, it's a metal and it is a non-metal. Clear on this? So it is clearly given by this, given in the book like this. Sodium is electronic configuration 2 8 11, and it leaves this electron, lost this one electron and becomes Na plus. Okay, 2, 8. Now it is complete. Okay, it is sodium cation because it is represented with positive sign, Na plus. Okay, likewise chlorine, electronic configuration 2 8 7, so it gains one electron from the sodium, then it becomes Cl minus, so it becomes 2 8 8, octet rule is complete. So it chloride anion represents the negative sign. Okay, in the form of symbols also they were represented. Na plus Cl gives NaCl. Okay, likewise for magnesium. For magnesium, the atomic number is 8. Magnesium, the atomic number is 12. So you have two valence electron. You will have valency is 2, right? So it has 2 extra electrons. So it's going to leave these 2 extra electrons. These 2 electrons will be gained by one chlorine atom. Okay. So this chlorine atom will gain one electron, this chlorine atom will gain one electron. So it becomes Mg2 plus, and this becomes Cl2 minus. Okay. So MgCl2. Clear on this? Cl. MgCl2. Cl plus 2 electron gains, it becomes Cl minus. Okay. So MgCl2. So this is how the metals and the non-metals will react. Okay. When the metals and non-metal reacts, it forms a ionic compound because it is charged one, right? Na plus and Cl minus. Okay, the ionic compounds are those compounds which are formed by transfer of electrons from a metal to a non-metal. Transfer of electron from a metal to a non-metal. Normal compound will share the electrons. For example, this is a hydrogen atom, this is a hydrogen atom, it has one positive electrons, right? So it will share, here both will share. Okay, but in case of this NaCl, Na will leave this one electron and this electron will be transferred to Cl minus. Okay, this is transfer of electron from one element to other element. Here sharing of, normal bonding means sharing of electron. Okay, so ionic compounds are those compounds which are formed by transfer of electron from metal to non-metal. Okay, next we'll have some specific properties for the ionic compounds. Okay, what are the properties we are going to learn? Physical nature, melting and boiling point, solubility and conduction of electricity. It's very easy. Physical nature. Ionic compounds are hard and solid due to strong electrostatic force of attraction between oppositely charged ions. Because Na plus and metal and non-metals are combining, so it has a since they are oppositely charged ions, their attraction is very strong. Okay, it has a strong electrostatic attraction, but it is brittle in nature. If you apply pressure, it will break. Okay, like for example the glass. Okay, next, melting and boiling point. Ionic compounds have a high melting and boiling point. Why? Because it requires more amount of energy to break the strong electrostatic bond. Okay. Next, solubility. These are soluble in water but insoluble in organic solvents like kerosene and petrol. Okay, it is only soluble in water. Okay, next, conduction of electricity. We discussed that physical nature is solid and hard. In solid items, electrons will not flow. Only when say electron flow, it will conduct the electricity. Okay, so in the solid state, the ionic compounds does not conduct electricity, but they conduct electricity in solution and molten state. Okay, if it is in the solution form or in the molten state, then it will conduct electricity, because the flow of charge is possible in the solution or molten state. They conduct electricity in solution or molten state because the electrostatic force of attraction between the opposite charged ions are overcome due to the heat. The heat produced in the electricity will overcome the attraction between the bonds. Okay, so thus ions move freely and conduct electricity. Okay, so these are the 4 properties of the ionic compounds. Okay, thank you.